Welcome back to some more geometry. Today we're talking about special right triangles. There's two main special right triangles we're going to talk about. We're going to talk about 45, 45, 90 degree triangle, 45, 45, 90 degree triangle, and of course our 30, 60, 90. These are two unique triangles that have a special pattern that helps us kind of find the sides. So previously we've done our Pythagorean theorem to find these missing parts. So now instead of having to do that so much, we can just work at this. So let's look at our first one. We got a 45, 45, 90 degree triangle. The relationship here is more from the legs to the hypotenuse. But first, let's look at the legs. So it's called 45, 45, 90 degree triangle because, again, those are the 2 degrees or the 3 degrees of the triangle. So we got two 45s and a 90. Now, see how in the theorem it doesn't even talk about the legs, the other leg? It's because last chapter we talked about how if our angles are the same, then our sides opposite of those are the same. So if this side right here is 12, then the other leg is, of course, is 12 because they are congruent to each other. This is an isosceles triangle. But let's look at the relationship here. The relationship happens from the legs to the hypotenuse. It doesn't matter which leg you're doing because they're the same. But the relationship, as it says, the hypotenuse is radical 2 times more. So when we do radical 2 times more, we're multiplying by radical 2. Now, since we're keeping this in exact form, we're going to avoid decimal answers. Since we have a 12, our hypotenuse here will be 12 radical 2. You really just put on a radical 2 on there, and it's good. Let's just kind of try it out with another number. So let's say I tell you this right here, it's 10. Makes this other leg over here 10, and makes our hypotenuse what, class? 10 radical 2. Same thing right here. What if, though, our legs have a radical answer? So let's say we have 5 radical 3 for our legs. Well, we're actually have to do a little bit of math here. So we're going to take that 5 radical 3 and we will multiply by radical 2. Now, when it comes to situations like this, when you have a value with a radical answer and then you multiply another radical to that, you're going to only multiply those two numbers with each other. So the 5 will be left as it is. So the answer will be 5, but then radical 3 times radical 2 gives us a radical 6. So we got 5 radical 6. All right, but what if we are dividing? What if we have a whole number for a radical? We got to find our legs. Now, the pattern backwards is we're going to divide. If we had to multiply the legs to get our hypotenuse, then we're going to divide by a radical 2 to get our legs. Doesn't matter which one you're going to, they're the same. So we're dividing by radical 2. So let's look at the actual math behind that, and then we'll look at the pattern that's going on here. So when it comes to doing something like this, we're going to take that whole value 8 and we're going to divide by a radical 2. Now, the issue with this fraction is not the fraction itself, but it's the radical. We cannot have a radical in the denominator. So to simplify this, we're going to multiply the top and the bottom by a radical 2. When that happens, on the top, it's just 8 times radical 2. We can leave all the radicals in the world on the top, in the numerator. We don't care about that. It's the denominator that's the issue. So on the top, we got 8 radical 2, but when we take a radical 2 times a radical 2, we get a radical 4. And of course, we spent a whole day learning what the square root of 4 is, class. It is 2. So we got 8 radical 2 over the whole number 2, and then we can reduce that. So 2 goes into 8 4 times. We get an answer of 4 radical 2. 4 radical 2. All right, so that's the math behind this and why it will always work. Let's look at the pattern here. So as you can see, we have an 8 and then we go to a 4 radical 2. Let's take another number. Let's take the number 10. If you go to 10 and we go to the sides, we end up getting a 5 radical 2. So the pattern here, as you start kind of see it, is we take our hypotenuse, whatever that is, we're going to half that value. So in our case, we're going to half that. The 8, we half it to 4, and then just put a radical 2 on it. So 4 radical 2, so that makes our hypotenuse 8. So if we had a 10, we're going to half the 10, get a 5, and just put a radical 2 in it. 5 radical 2. What if our hypotenuse is 20? Well, that makes our legs 10 radical 2. But what if our hypotenuse is an odd number? Let's take the number 15. So our hypotenuse is 15. The idea is still the same. We can half that. So I know I always say avoid decimal numbers, but in something like this, it is okay. So half of 15, we get 7.5, and then just slap a radical 2 on it. The more proper way to kind of leave this side is to leave it in fraction form. So 15 over 2, radical 2. But I will take either one of these two answers. They're both correct. So in our practice problem right here, they give us a hypotenuse of 5 in our 45, 45 right here. So you got to find the leg. So hopefully take the time, pause this, and do this for a bit. But all right, totally passed it. Again, we're going from hypotenuse to leg, so we're going to divide by radical 2. So we're going to do our little pattern. We're going to half 5, get 2.5, and then slap a radical 2 on that. So our answer is 2.5 radical 2, or as a fraction, 5 over 2 radical 2. This one over here, we're going from the legs up to the hypotenuse, but this time we do have a radical value. Again, to go from the leg to the hypotenuse, we're going to multiply by a radical 2. So as the formula goes, we take 9 radical 2 times another radical 2. Gives us 9 radical 4, but like we said, we spent a whole day learning what the square root of radical 4 is, which is 2. So we got 9 times 2, or the final answer, 18. All right, and that's 45, 45, 90-degree triangle. Let's look at our 30, 60, 90-degree triangle. Again, it's called a 30, 60, 90-degree triangle. Why? Because those are the angles of our triangle. So we got 30, a 60, and a 90-degree triangle. So the formula here, let's kind of look at that. I'm going to draw a very generic right triangle. And now everything right here, as we look at this, is the hypotenuse is twice as long as the smallest leg. The long leg is radical 3 times as long as the smallest leg. So everything is based off the smallest leg here. So the smallest leg is always across from the smallest angle. So if our 30 is right here, our leg down here will be x. So that's where everything is based off. If our smallest leg is x, then we go ahead and change everything else based on that. So like it says right here, the hypotenuse is twice as long. So we go from the small leg to the long leg. So to go from the small leg to the hypotenuse, sorry, I said long leg, but it's hypotenuse. We're going to multiply by 2. So we end up getting 2x. So the value of our hypotenuse is always twice as long, or 2x. To go from a small leg to our long leg, as it says, we're going to multiply by radical 3. So we're going to take this times radical 3. So x times radical 3 just gives me x radical 3. Similar to like the radical 2, you're going to just slap on that radical 3 and just let it be unless you actually are able to multiply it. Let's look at so we're going to do this one over here on the right first, and then we'll come back and look at this one. So we got a 30, 60, 90-degree triangle. And in this case, the 9 is our small leg. So let's start with the hypotenuse. To find our hypotenuse, we are multiplying by 2. So 9 times 2, we get 18. And then to find our long leg, we're going to take that times a radical 3, giving us 9 radical 3. It's just that simple. But let's look at this problem right here. We have an odd number for the hypotenuse. So again, to go backwards, since our hypotenuse is 2x, or twice the value of our small leg, to go backwards, we will divide by that value of 2. And same thing over here, to go from the long leg to the small leg, we will divide by radical 3, which we'll run into a problem here in a bit on that. So here we got 13, and we're going to go ahead and divide by 2. So you can either write it as 6.5, or you can leave it as 13 over 2. Either one is correct. Now we're going to go to our long leg, and that's the pattern goes from small leg to long leg. We're going to multiply by radical 3. So you can either have 6.5 radical 3, or in fraction form, 13 over 2 radical 3. Either one's correct. All right, so let's practice these two right here. So we'll start with the one right here on the right. We got 15 for the hypotenuse. So go ahead and pause and try to do both of these. So we're going backwards. We're going hypotenuse to small leg. So we're going to divide by 2. We're going to be getting 7.5, or 15 over 2. And then we're going to go from small leg to long leg. So we're going to multiply by a radical 3. So we get 7.5 radical 3, or 15 over 2 radical 3. Let's look at this part right here. This is a good one right here. This time our long leg is the one that usually has the radical. Doesn't have one. It's just a 12. So again, we're always trying to go back to our small leg here. So we're trying to get back to the 30. So the opposite of the 30 degree right here. So if this is 12 and my small leg is my x right here, to go from long leg to small leg, we're going to divide by a radical 3. So similar to the 45, 45 with divided by radical 2, there is a pattern, but let's just look at the math. So we're going to take 12 and we're going to divide it by a radical 3. Again, the problem is not that it's a fraction, it's the radical and denominator. So we're going to go ahead and multiply the top and the bottom by a radical 3. In doing so, we end up getting 12 radical 3 in the numerator. On the bottom, we get radical 9. Now, again, we spent a whole day learning what square root of 9 is. Hopefully, you guys remember it's whole number 3. So we got 12 radical 3 over 3, and then we reduce that. Now, this one happens to reduce, so that's nicely. So we end up getting 4 radical 3 as an answer. And then we're going to take that value to get our hypotenuse. We're going to multiply by 2, so we end up getting 8 radical 3. So when you're multiplying a whole number with a radical with a whole number, you're only multiplying the whole numbers with whole numbers. You're going to leave the radical alone. Just similar like right here, when we multiplied 9 radical 2 with a radical 2 times a radical 2, we multiply radicals with radicals. So rules still apply here. So we get a radical 2. All right, but let's say you get a number that doesn't divide by 3. So the pattern again still goes similar to the radical 2. Whatever this number, instead of halving it, we're going to divide it by 3 and then slap a radical 3 on. So here it makes sense. I got 12 radical 3. I slap my radical 3 and I'm going to divide it by 3. It reduces. But what if it doesn't? Let's say they give you the number 10. So to go from 10 to my small leg, same concept, put a radical 3 on it and then divide by 3. But it doesn't reduce. So this is where you're going to have to leave it in fraction form. And then we go from the leg, the small leg, to the hypotenuse, we multiply by 2. But when we multiply by 2, we're only multiplying the 10 by 2. So we get 20 radical 3 over 3. So that's the pattern here for a number that's not divisible by 3. All right, this last problem right here is a word problem that you'll run into, but it's actually a old problem from a ACT. So you will see this more than just in this class. But here we got an equilateral triangle that's sides 12. So that means equilateral means all sides are the same. So it's 12, 12, and 12 right there. And again, all angles are the same, 60, 60, and 60. Now, remember to find the area of a triangle. To find the area of a triangle is base times height divided by 2. So we got our base in this situation. So area equals base times height divided by 2. We have our base. It's 12. So we're good on that part. We're missing, though, our height. So when you draw the height on an equilateral triangle, it also splits that angle in half. So not only does it split the sides in half, so we got 6 and 6, it splits our angles. So now we create a special right triangle, or a 30, 60, 90 degree triangle right there, making this side right here on the bottom, the 6, the small leg. So that makes my height the long leg. So to go from my small leg to my long leg, what do we get, y'all? We multiply by a radical 3, so we get 6 radical 3. So here in this particular problem, it's just recognizing the special triangle that's formed when we draw that height right there in the middle. So our height then is 6 radical 3. Now, you can multiply 12 times 6 and divide by 2. I like to do it beforehand, so I'm going to divide the 2 into the 12 and get a 6, and then I'll multiply these two numbers right here. So 6 times 6 radical 3 gives me a 36 radical 3. Again, this is area, so it's units square, since we don't have a set unit to measure. All right, y'all, that's it. Hopefully that helps. Bye.